Hi guys, now we're going to look at section 1.4 notes. It's about quadratics equations, and let's get started. Okay, so for this section we're going to focus on the solving methods. As you can see, there are quite a few. Now, you should have seen all these before from the previous classes, so this is going to be a little bit more of a review for everyone, I hope. If not, it's okay. We'll take some time to kind of refamiliarize ourselves with this. Okay, so factoring, use the zero factor theorem. Make sure you set the equation equal to 0. If you don't set the equation equal to 0, it doesn't work. Square root properties, there are two types. One is just your regular x squared equals some constant, and we just square root both sides. And the second type is when you have x minus a quantity, then the whole thing squares equal to another constant. Okay, so just want to make sure that you know how to handle these two, and of course we'll practice a little bit more on these. The third one is complete the square. Now, depending on your previous classes or your instructor, some of this may not be covered, so we'll go through a couple of these just to make sure you know what's going on. Sometimes complete the square is actually easier and faster than other methods, so it just all depends. Quadratic formula is something that you have to know. Okay, if you don't know quadratic formula, we are gonna have problems. Okay, and page 128 in your textbook has some best strategies. Feel free to take a look at those, and I will also talk about some of those as we work through our problems. And the last part, the usage of discriminant. The discriminant tells you what kind of what kind of solution we're gonna get. So either you're gonna get two solution, a single solution, or two complex solutions. So just rephrase: two real solutions, one real solution, or two complex solutions involving i's. So if you just want to know what you have, that's a really quick way to check. Alright, let's go ahead and work on some problems. Okay, so the first problem we're going to do is involves factoring. Okay, and that's going to be x squared minus 15 equal to x. Again, when it comes to factoring, must set equal 0. Okay, equation has to be equal to 0. If it doesn't set equal to 0, it doesn't work. So we're gonna move minus 2x on both sides. Okay. And this part, so let's see if we can factor this. When the number in front of the x squared is 1, right? That makes your life pretty easy. All you gotta figure out is which two numbers that multiply equal negative 15 and add equal negative 2. Okay, that's all we need when number in front of x squared is 1. So the only way to get x squared is x times x. So you kind of get the x's automatically. And in this case, the only two numbers that multiply give you negative 15 and add to negative 2. It's going to be negative 5 and plus 3. Okay. So once you've factored, and then what we can use is that we can use the I want to make sure I use the correct terminology, just because this book used something that's slightly different. Okay, I believe this book, they called it so I'm gonna look it up really quick. I call it zero product property, but in this book they call it can't find it for some reason. It is on page 121. It's called the zero factor theorem. What it says is, if you have a quantity multiplied by another quantity equal to 0, then individually each quantity is equal to 0. And then we can use that idea to solve it. So in this case, what we have is x equal 5 or x equal -3. Okay? Alright, so if you can factor it, then we can use the zero factor theorem to finish the problem. Alright, let's move on to the next one. Let's go to d minus 10, d plus 10 equal -6. Okay, the way that this problem is written is a little weird. They put a d in the back instead in the typical front, but it doesn't matter. We can just go ahead and distribute. Alright, so you get d squared minus 10d plus 10 equal -6. Just like earlier we said, set one side equal to 0. So we get d squared minus 10d plus 16 equals 0. And I think this one is also factorable. You get a d and a d by itself because of the d squared. And I think the two number that we need is going to be the -2 minus 8. -8 times -2 is positive 16. And -8 plus -2 is -10. So I think we're good to go. So d equal 8 or d equal 2. Okay, if you set this equal to 0. Alright. Okay, so here's factoring. Now, just a heads up, factoring is pretty easy to use, but only if the equation you're dealing with is easily factorable. Okay, there are some pretty complicated factoring, but if it's too complicated, I might think about a different method. Alright, square root properties. So for the first one, you have m squared minus 25 equals 0. So if we go back to our square root properties, notice we said it was either x squared equal to c or x minus a quantity squared equal to c, right? This problem looks a lot more like this one right here. So we're going to make this look like this. Okay? So this is the complete opposite from the factoring. Remember, in factoring, we have to set equal to 0. And when it comes to square root properties, we don't want to set equal to 0. Okay, we want the x squared by itself. So in this case, I'm going to add 25 to both sides. And then I'm going to square root both sides. Okay, now this equation originally comes squared, so make sure your answer includes plus minus signs, because positive and negative answer will both work. And we're done. Okay. Alright, now, can I factor this problem? Yes. But am I going to factor it? No, because factoring takes too much time and too much work. Okay, this is factorable by using difference of squares. But too much time. Square root property is much easier. Okay, alright. Problem number 2, x squared equal 27 over 16. So this is even easier setup wise, right? It already looked like this. So I'm going to square root both sides. Okay, and then this problem, we're just going to have to clean things up a little bit. We're going to, when you square root a fraction, it means you square root the top and the bottom. The denominator is pretty easy. Square root of 16 is 4. Square root of 27, I need a little bit of side work. I know 27 is square root of 9 times square root of 3. So this is 3 square root of 3. And then we're done. Okay, so the answer is going to be plus minus 3 square root of 3 over 4. Alright, the third problem, the b minus 3 squared plus 7 equals 3. This looks like the type 2 of our square root property, right? We have a variable subtract a number, quantity squared. Okay, so let's make it look like this. Alright, let's make it look like this. So I'm going to minus 7 on both sides. Okay, and we're going to square root both sides. So if you square root both sides, you get b minus 3 equal plus minus square root of negative 4. And from here, we know how to handle square root of negative 4. Right, remember the last section? Right, deal with i's. So this is plus minus, this is plus minus I square root of 4, which is plus minus 2i. So to finish the problem, I'm going to add 3 to both sides. So the answer will be b equals to 3 plus minus 2i. Okay. Now, can you solve this problem a different way? Yes. But it takes too much time. So don't do it. Okay, recognize the pattern, recognize the format, so you know how to handle a problem in a faster and easier way. Okay, I have had students that try to do a different way by multiply everything out, try to factor. And by the way, this problem is not factorable. So yeah, that student was very frustrated because nothing works. All right. The next part is complete the square. Okay, so complete the square requires a little bit of pattern recognition. So for example, if you remember what these are, x plus 1 quantity square, x plus 2, x plus 3, x plus 4, x plus 5, quantity square, and so on. We're only going to do a few of them. We're not going to do all of them. Okay. And so now hopefully you have some of these memorized. X plus 1 quantity square, that is x plus 1 times x plus 1. If you FOIL that, that's x squared plus 2x plus 1. And this is x plus 2, x plus 2. This is x squared plus 4x plus 4. So on. If you FOIL all these, this is going to be x squared plus 6x plus 9. X squared plus 8x plus 16. X squared plus 10x plus 25. And so on. Okay, the big pattern recognition is this. Notice, right? These all have the same format as x plus a number, right? You could make it x minus a number if you want, but that's but once you know the pattern, the idea is the same. Okay, notice the number in front of the x is always half of your number here. Okay, and the constant with the blue arrow is always the square of the number in the parentheses. Okay, again, the red arrow means the red arrow, the number in front of the x, is always half of the number. If you take half of that number in front of x, that will also give you the number in front of the parentheses. And if you think about taking square root of the number in the blue after FOIL, that will always give you the number in here. Okay, but when it comes to complete the square, what we always do is, this is unknown. Okay, we need to come up with with these numbers. All right. So, well, I'm gonna leave this chart here, and I'm gonna erase the stuff on the left, so we're not, losing information. But we'll go back and revisit the old stuff. But it's much easier if we actually just do it on the same page. Okay, here we go. All right, complete the square. X squared plus 6x equal -5. Okay, complete the square will allow us to use this. Okay, so check this out. Hey, look at my equation. I have x squared plus 6x. That looks awfully like this right here. Right? So that means, hey, you know what? I need to figure out what my constant is to make it to a perfect square. So to figure out a constant, what I will do is I would take the number in front of x. I'm going to take half of it, and then I'm going to square it. And I'm going to add this to both sides. And if I do that, I get x squared plus 6x plus 9 equal -5 plus 9. Right? I added 9 to both sides, so that means I'm not changing the problem, not changing the question. But this allows me to factor. This is x plus 3 quantity squared equal 4. Okay, and then from here, square root property. X plus 3 is plus minus square root of 4. X plus 3 equal plus minus 2. So x equal -3 plus minus 2, which means we get either -5 or -1. Okay, -5 or -1. So if you recognize the form, it'll be pretty fast. And also notice, if you want to use this complete square, the number in front of the x, they're all even numbers. Okay, you can do complete square with odd numbers in front of the x. That'll be a little harder because you have to deal with fractions. Right? So a lot of times when I see these type of questions with a number in front of x is an even number, I'm only dealing with x squared, I lean towards complete square. Okay? Alright, next question. You have r squared equal 4r plus 10. Okay? To complete the square, I'm going to move the 4r to the other side. Okay? Right? Notice that 10 stays there. Okay? Complete the square, you don't set it equal to 0. Alright. So now I have my r squared minus 4r, and I need to figure out what number I had to add to both sides. Okay, to figure out which number to add to both sides, take the number in front of the r or the b. If we're thinking about ax squared plus bx plus c, right? We take that number, we divide it by 2, and we square it. And that's the number we're going to add to both sides. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we're going to add 4 to both sides. Okay. So this is r squared minus 4r plus 4. And notice this number right here is always the number that goes inside the parentheses when you factor. Okay. So this is x minus 2 quantity squared equal 14. Square root both sides. X minus 2 plus equal plus minus square root of 14. So add 2 to both sides. X equal 2 plus minus square root of 14. And then we're done. Okay. Alright. So yeah, completed square for most part is pretty it's a little easy to use and save you a little bit of time if you know how to use it, and the number in front of the x is even. Right? But either way, just want to make sure you're aware of, because this is going to set up our next topic, the quadratic formula. Okay, quadratic formula, if you don't remember, you need to remember it. That's x equal negative b plus minus square root of b squared minus 4ac over 2a. If you got issues, check out YouTube for quadratic formula songs to help you memorize. Okay, there are songs on YouTube that you can check out that'll help you memorize. Again, this formula, everything comes from ax squared plus bx plus c equals 0. Okay. All right. So let's look at our problem. If you got 2p squared plus 8 equal negative 9p, I had to set it equal to 0, so this is going to be 2p squared plus 9p plus 8 equals 0. Is this factorable? I have no idea. Okay. Usually when the number in front of the square quantity is not 1, I don't think about factoring, unless it's something that's really easy to recognize. Okay. Alright, so let's go ahead and plug that in. So in this case, a equal to 2, b equal to 9, and c equal to 8. And we're just going to plug it in. So x equals negative 9 plus minus 9 squared plus minus 4 times 2 times 8 over 2 times 2. Okay, I know the question asks for check the discriminant first, but the reason I won't do that until now is because discriminant is embedded in the quadratic formula. This right here is the discriminant. Okay, so in this case, my discriminant is 81 minus 4 times 2 is 8 8 times 8 is 64, and which is 17. Okay, my discriminant is 17. Side note, if discriminant is greater than 0, this means then you have two real solutions. If discriminant is equal to 0, then you have one real solution. And if the discriminant is less than 0, then you have two complex solutions with I. Okay, right? Because if the discriminant is negative, you are taking square root of a negative number. So that means you are going to end up with i's. Alright? So, to finish this question, so what we can do is I'm going to erase some of these. Luckily, this is recorded, so you can always go back and take a look. Alright, and so let's finish the question. -9 plus minus square root of, we know the answer is 17 over 4. And that's our answer. We're done. I can't do anything with square root 17. So this is it. The answer is -9 plus square root 17 over 4, or -9 minus square root 17 over 4. Okay. Quadratic formula is actually the best because quadratic formula will work on any type of quadratic equation. It's not factorable, no problem. Throw into a quadratic formula. Okay. The only thing about quadratic formula is that it has to be in this format, and potentially it takes a lot of time because you have all the little calculations that you have to do within the formula, but it is the one that works on any quadratic equation. So that's why quadratic formula is super important. Okay, we're not going to derive quadratic formula because it's kind of cool to know where it came from, but it came from complete the square, and we're not going to spend time on that. Okay, to derive the quadratic formula. All right, next you have -3w squared equal -w minus 2. I'm just going to go ahead and set one side equal to 0 because I want to use quadratic formula. So I'm going to add w on both sides and add 2 on both sides. So -3w squared plus w plus 2 equals 0. So my a is -3, b is 1, and c is 2. Then we'll plug everything in. Be very careful when you're dealing with negative numbers. I always like to put my numbers in first and use parentheses as appropriate. So -1 plus minus 1 squared minus 4 times -3 times 2 over 2 times -3. Okay, notice I adding parentheses, right? Even though it's not in the formula. Make that a good habit so you won't lose signs. 1 squared is 1, minus 4 times -3 is -12. -12 times 2 is -24. So 1 minus a -24 over -6. 1 minus -24 is a 25, which is good. I like perfect squares. So this is just -1 plus minus 5 over -6. Means I have -1 plus 5 over -6 If that's the case, I have 4 over negative 6, which is 2 over negative 3. Or, if I have the negative 1 minus 5 over negative 6, I get negative 6 over negative 6, which is 1. So 2 different solutions. I get the 2 over negative 3, or I get the 1. Now, is this factorable? Yes, this is definitely factorable because my discriminant is a perfect square. I get 25. Okay, if the discriminant is a perfect square, the problem can be solved by factoring. Okay, but like I said, the number in front of w squared is negative 3. If it's not 1, I really don't want to have to deal with it unless the question told me to factor. Alright, so that's the reason why I'll probably use quadratic formula if I can. Okay, rational equations. The last one. I know it's kind of hard just kind of listen to me talk about math, but we will get through this. Okay, and we have dealt with the rational equations before in the earlier sections. Let me change back to black. Okay, so 10 over x minus 5 plus x equal 1 plus 2x over x minus 5, right? If you remember from the previous section, our common denominator is x minus 5, and we're going to multiply both sides by x minus 5. Okay, and this means we have to distribute. Okay, alright, so I'm going to work on the left hand side first. If we distribute, x minus 5 cancels out, so I get 10. Plus, if I x minus 5 times by the x, I get x times x minus 5 equals. Right hand side of the equation, 1 times x minus 5 is x minus 5. Plus, x minus 5 times by 2x over x minus 5. X minus 5 cancels out. I'm left with 2x. Okay, so combine like terms on both sides, clean things up. I get x squared minus 5x plus 10 equal x minus 5 plus 2x. A little bit more cleaning up. I get 3x minus 5 on the right hand side. Now from here, I don't really care which method you use. I'll probably set it equal to 0 just because the number in front of x squared is 1. Hopefully it's factorable. We'll see what happens. I'm going to minus 3x on both sides, and I'm going to plus 5 to both sides. I get x squared minus 8x plus 15 equals 0. I think this one's actually factorable. I think we did this one earlier. This is x and x minus 3 minus 5. Okay, so this is telling me x minus 5 equals 0, or x minus 3 equals 0. So leads to x equal to 5 or x equal to 3. Okay. Now, if you think we're done here, then that means you're going to lose some points. Okay. When you're dealing with a rational function, right? Rational equation, you have to check for restriction. Our restriction is x minus 5 cannot equal to 0, right? Denominator is never equal to 0. So this means x cannot equal to 5. So the answer we found here is extraneous. extraneous means it's the answer that does not work. So the only answer that works is x equals 3. X equals 5 is not a solution. Even though it looks like it's one, but it's not because of our restrictions. Okay. The first time we did this problem in the earlier sections, we ended up with linear equations. This time we're going to end up with some quadratics. So, okay. The last one, I saved it just for you guys. A little bit messy, but it's not too terrible. I won't do that to you guys because I know you guys love algebra so much. Okay. We did a problem like this earlier as well. Let's go ahead and double check. I think this one actually is pretty straightforward. This is an n plus 3 times n minus 2. So that means our CD in this case is going to be n plus 3, n minus 2. Okay, because n plus 3 times n minus 2 contain both of these. And we're going to multiply that on both sides. Okay, now on the left hand side, I'm going to distribute the n plus 3 times n minus 2 into both fractions. Okay, so if you look at it, the first fraction with the n plus 3 on the bottom, it'll get canceled out, so we're left with 6 times n minus 2. Plus, second fraction, everything cancels out, so you're left with 20. Equal. Now, on the right hand side, n minus 2 and n minus 2, that will cancel out. So we're left with 5 n plus 3 parentheses. And here we go. Let's go ahead and clean this up. 6n minus 12 plus 20 is 5n plus 15. 6n plus 8 is 5n plus 15. So I think this one ended up becoming linear. So minus 5n on both sides and minus 8 on both sides. You get n equals 7. Okay. This problem doesn't even require any quadratics. Alright. So, okay. Alright, so, but again, rational equations, clean it up by multiplying both sides by the common denominator. Okay, super important. Make sure you know how to find the common denominator. And then, depending on the equation that we end up with, either quadratic or linear. I won't do that to you, giving you guys a cubic. Alright, so no worries. Okay, so that's it for this one. Again, any questions? Email me at whsieh@grcc.edu, or you can call 616-234-4729, or you can catch me on Zoom on our office hour from 6 p.m. to 8 p.m. Okay, good luck, and let me know if you got any questions. Okay, bye.